bit of conversions. So we're going to talk about the relationship between something in polar form and something in rectangular form. So polar form is what we've been working with last week or so. It's with an r and a theta. So you figure out how much it rotated, and then you went out from the pole. And then the rectangular coordinates are x and y coordinate pair from what we talked about and all types of other math for this. So essentially what we can do is, since it's kind of on a coordinate plane, or you can kind of see a horizontal axis and a vertical axis, there's actually a way to find a representation in both polar form and rectangular form for all points that we put along our polar coordinates. So that's essentially what we're going to talk about today, is the formulas that we can use to convert back and forth between polar form and rectangular form. So if it starts in polar, and usually you can tell it's in polar because the second number is some sort of angle measurement, so it's going to be a degree, it could be a radian. So if you have some sort of angle measurement second, then you know that it's going to be in polar form. Okay, so that means the first number is an r and then a theta. And so if we have an r and theta, we can convert it into an x and y by using these formulas. Okay. It actually stems from being able to draw a right triangle with the pole, so that's why there's a cosine and sine. So in order to convert your r and theta into an x value, so some sort of horizontal distance, you take your r, whatever your ring number is, and then take cosine of your angle, and that will give you the x distance to get to that point. Okay, and it just tie back in why it's cosine. So remember when we did the unit circle, all the way around it, all the x values were cosine. So that's why cosine helps convert stuff into x. Okay? Because it's also like the adjacent side, because it's the horizontal distance. So then to convert your r and theta into a y value, you take your r and then do sine of your angle, and that would convert it into a vertical distance. So if you use cosine of your angle and then take it times r, that'll give you the horizontal distance out to get to that point. And then r sine of theta will give you the vertical distance to get up to whatever point you're looking at. So that's how you convert something from an r and theta to an x, which is a horizontal distance, and a y, which is a vertical distance. So those are the formulas to convert from polar to rectangular. Okay? So then to convert from a horizontal and vertical distance into a distance from the center and then a rotation, the formula is a little bit like this. And again, this actually stems, again, still from right triangle stuff. So to find r, it's the square root of x squared plus y squared, which actually r is like the hypotenuse of any right triangle that you draw. Because if we have a point xy over here, like I said, all this kind of stems from a right triangle that you can draw with this point. Okay? So this would be like an x distance, this would be a y distance, this is the r, and then if you rotate here, that's the theta. Okay, so it's all tied into a little right triangle that you can draw with any point that you plot around the coordinate plane. Okay, so the x and y distance you can get if you have r and theta by using those first two conversions, and then if you have r and theta, you can get the if you have x and y, you can figure out the r, which is like sort of the hypotenuse of that right triangle that you can draw. Which, if you look at this, it's just kind of a rearranged version of the Pythagorean theorem, because it was usually a squared plus b squared equals c squared. But if you're always finding the hypotenuse, then you just take your two legs, square them, and square root them. That'll get you the r. And then to get that rotation, since this is our theta, we have the opposite and adjacent side, which is why it's tangent. And then to convert things into angles, we had to use inverse. So it all stems from all of our right triangle stuff that we did back a few months ago. Okay? So again, if you have r and theta, and how you can tell the difference, like I said, they're both going to be in points. They're both going to look similar. So the one thing that's easy to point out is the theta, the angle. So if your second number is an angle of some sort, whether it's in radians or degrees, then you know you have a polar coordinate. If you have two just plain numbers like a 2 and a 5, or -6 and a 2, or something like that, then you have an x and y, and so you're going to convert it into r and theta. And then I also try to do that while describing in the directions. whether you're going from polar to rectangular or rectangular. Questions on that? Okay. So those are the formulas. So now we're going to break it down, and we're going to start with this first set of formulas. So I'm going to give you a polar point to start with, and we're going to convert it into a horizontal distance and a vertical distance. So like I said, whenever you're doing this one, I will try to tell you in the directions what we're doing. So we're converting it to a rectangular point. So when I ask you to convert into a rectangular point, that's converting it into an x and y. Now I will say, to use these formulas, sometimes your angle is going to be given to you in radian mode, like this was a radian. The second one's a degree. So there actually is a way to change them on your calculator. So I'm going to show you that. Also, if you don't like necessarily to change them on your calculator, just like we did with distance, you really want to look up what that is in degrees. The only thing is, we're not actually graphing those, so I don't have the little circle chart on these notes. You have to pull out something else to look it up. So that's why today I'm going to show you how you can just switch them on your calculator so that you can use a radian instead of a degree. So that's why I have these big capital letters and not yellow. I'm just reminding you. And actually in calculus, we are working with radian mode. So if you're using one of my calculators, always double check what mode you're in. So how you can tell the mode in the calculator, so I'll do that real quick before we actually go through the example. If you're on my blue calculators, down at the bottom of the screen, you'll see some little letters. You should see the letters DEG, that's in degree mode. If you see the letters RAD, that's in radian mode. And how you switch that, on my blue calculators, there's a little button that looks like this, okay? It's actually in the very top row of buttons. So it's right next to second. There's letters on it, DRG. If you click that button, then you can just arrow over and change the degrees to radians in your calculator. So usually it defaults to degrees, but if you hit the DRG button and then just scroll over to radians, which is what we'll need for this first example, and then hit enter, now your calculator's in radian mode, and so you should see in the bottom corner the letters RAD. Okay? Now different calculators do it different ways. On some calculators, like my board calculator up here just has a button. So right now it's DEG, and if I click that, it switches it to radian mode. So then that's how you switch them on the calculator at different things. So there's also a third option, which I've never ever used. So I don't really know what rad is, but so I just use degrees for radians. So that's how you can switch. So you can see the letters RAD on your screen. That means it's in radian mode. You see the letters DEG, it's in degree mode. So for this first one, I need to be in radian mode. That's radian. Okay. Everyone good on that calculator thing? And like I said, if you really want to, you can pull out your other sheet and look up what the degree is, so that we don't worry about switching the mode. But sometimes, if you don't have that, it is always good to know that you don't necessarily have to look those up. You can just use your calculator. Just switch the mode. So here's my R. Here's my theta. And again, I knew it was an R and a theta because if you look at that second value, it's a radian. So if you have some sort of angle measurement, that's a polar point. So what we're going to do is convert it into an x and a y. So to do that, you're going to take your R times cosine of your angle, which our theta in this case is pi over 3. So I'm going to do 2 cosine pi over 3, and my calculator is in radian mode, so it'll accept the radians. You also have a pi button, it's right underneath the ln. So I just do 2 cosine pi over 3, and that's 1. And then to find y, I do 2 sine pi over 3. And so that's 1.73. And then how I want you to write your final answer, since this is now a point. So we went from an R and theta point. This is your x and y. I want you to write your final answer in a coordinate form. So we're going to 1, 1.73. And that's the x and y value to get to that point. Excuse me. questions on that, Cory? So if I were to plot that out, and I don't have my circle grid to do that, so 2 and pi over 3 is somewhere in here, and so then we would have counted out 2, so that point is right around there. So it makes sense that the x to get there is 1 to the right, and then the y to get there is about 1.73 up. Okay, so again, all of it is locating this point. It's just the original location for that point was the r, so the distance from the center, and then a rotation from that horizontal axis. And then this second format of that point is the horizontal distance and the vertical distance to get up to that point. So yeah, this was the r and theta location, and then we convert it into an x, y location. Does that make sense? So it's still up in that 1.73 range. So that was the original point. Now it's the next point. Alright, what's different about this one? It's an angle it's still an angle, it's in degrees. So if you're switching your mode to calculator, I had it in radian mode to do the first one. Now I have to switch it back to degree mode, so just hit your DRG button, arrow back over to degree, hit enter, and now it's back in degree mode. So it's just a couple quick clicks to switch it. You just have to, the one thing that gets tricky about it is just have to remember, just look at what you have to start with, so that way you make sure your calculator is in the correct mode before you start typing in your formula. The nice thing is it's the same information, so r and theta is used for both little formulas. It's just if we're converting it into an x, we use cosine, because again, cosines, those are all of our x values around the unit circle. It's also like the adjacent side. If you draw a little triangle with this, adjacent side, opposite side, your y. So that's why we use sine for y. So I switch my calculator back into degree mode. So I do -5, and then cosine 45, and that is negative 3.54. I usually round to 2 decimal places. Just typically I don't usually specify, so usually I'm not super picky about how you round, but usually if we're converting into x and y, I usually round to 2 decimal places. So -45 cosine of -5 cosine of 45 is -3.54. So I'm going to convert into to y. So I just use that same information, only I use sine. So that'll give me the vertical distance. So that's -3.5. It is possible for you to get the same x and y. A lot of times if you're using 45 degrees or pi over 4, again, that's like a quarter. It's like a half a distance in between the x-axis and the y-axis. That's why a lot of times those are. So again, our final answer. Right as coordinate. That is our. And that makes sense because if you think about where that point would have been plotted, we would have rotated the 45, but then to get -5 would have counted backwards. So it would have been down here in quadrant 3. So again, for our x and y to both be negative, it has to be in quadrant 3. Let's do one more. What mode do I have to be in to do the third one? Degrees, yep. Again, I see my theta here is a degree, so it's going to be 4 cosine of -240. The nice thing also with formulas, you don't have to worry about converting the angles anymore, because a lot of times when we saw a negative angle, we thought, oh crap, we need to change that, we need to add 360 to it. But with the formulas, it can take negative angles. So the nice thing is you don't have to worry about doing anything to the -240. You can just type that in your calculator as is. So do 4 cosine -240, and that'll give us the correct x value, which is -2. And then with this one, we're going to switch to use sine, and that'll give us our y value. So we have 4 sine -240, so that's 3.46. So write my final answer as an order pair. And there's the x, y for that coordinate. questions about that converting? It's pretty straightforward. The big thing is if you're gonna keep it as a radian, just make sure you change the mode of your calculator. Otherwise, if it's so just watch that as you're going through and working this out. Okay, so I'm gonna talk about the next conversion. And that one, there's one little tricky thing, because if you take something from x and y and you convert it into an angle, there's actually several different ways we can get an angle. It can rotate counterclockwise, clockwise, whatever. But what we want is the positive angle. So on this next slide, whenever you're converting into theta, so the angle from x and y, there's a couple little fixes that you might have to do. Sometimes the calculator does a good job of converting it, but it doesn't always give you the angle that you want right away. So there's a couple little things we have to do to fix it. So that's what this next slide is covering. Okay. So we saw these formulas on the front page. I'm going to put big stars next to theta because that is the only formula that when you're using, that you have to worry about. Okay, what else do I have to do? Okay, because the other two formulas that we just did with x and y, using the r cosine theta and r sine theta, we can just type it in our calculator. We don't have to really worry about doing anything extra once we typed it in. Same thing with r. You can find r just using that regular formula, square root of x squared plus y squared. It's just when you're converting theta using the tangent formula that the angle you get may not be the right angle right away. Okay? And that all depends on what x and y are originally. Okay? If x and y, if there's a negative in there, if you put a negative into tangent inverse, it doesn't always read that negative correctly. Okay? So you have to watch out for negatives when you're putting it into the tangent inverse formula. Okay? If x is negative at all, okay, the angle it gives you is actually off by a half a rotation. And we're going to keep these in degrees to make it easier for you, so you don't have to worry about converting it into radians. So just make sure whenever you're converting into theta, make sure you're in degree mode. So since it's off by half a rotation, if x is negative, you're going to add 180 to whatever you get, and that'll give you the proper angle. Now this thing that's in parentheses, y, it doesn't matter if it's positive or negative. If x is negative at all, kind of the negative on x trumps whatever y is, you have to add a half rotation. So if x is negative and y is positive, you add a half rotation. If they're both negative, you still add a half rotation. Okay, that's where it gets a little bit tricky. So if x is negative at all, the angle that you get from the tangent formula is off by a half rotation, so add 180. Now if just y is negative, it's actually off by a whole rotation. So if y is negative, you're going to add 360 to it. So again, if x is negative in any format, well, it doesn't matter what y is. So that's why y can be either negative or positive. You have to add a half rotation. If just y is negative, you add 360. So use this little code to help you with the thetas. And like I said, this is the only extra thing you have to do with any of the formulas I give you. Because really we're working four little formulas. We're converting into x and y, and then converting into r and theta. So the only thing you have to worry about when you're working with the formula that you have to do a little bit extra with is the theta. Okay? And that's just if one of these two original numbers is negative. So if x is negative at all, it's off by half rotation, so add 180. If just y is negative, it's off by a whole rotation, so add 360. If they're both positive, then don't have to worry about anything. So it's just if one of those is negative. Because if you put negative into tangent inverse, it doesn't always give you the right angle. Okay. And like I said with these, it's just easier to work in degrees. So just make sure your calculator's in degrees when you're converting into r and theta. Because if you're in radians, if it's a half rotation, you have to have pi or 2 pi. So it's just easier to think in degrees, 180 or 360. So this is an x and a y. Oops, that y was. And for one thing, I told you to convert it into polar. The other thing to help help you recognize that it's an x and y point. Look at that second number. It's just a regular number. It's negative 12. There's no angle part to it at all. So that means that this is an xy coordinate, and we're going to convert it into an r and theta. So I'm going to convert it into r first. So r is the square root of x squared plus y squared. So it's going to be the square root of 5 squared plus negative 12 squared. I put negative 12 in parentheses, just as a reminder. A lot of times the calculator, if you type negative 12 squared in just as is, it actually doesn't square the negative. So if you want to type those in, you make sure you put it in parentheses. Otherwise it won't square the negative. Because whenever you square a negative, what happens to the negative? You square a negative. What? It goes away. So whenever you're taking anything inside this formula, make sure this after you square it, there should be no negatives left. Okay, so 5 squared is 25. What's negative 12 squared? 144. If I add those two together, yep.
That's perfect.
Yep. Now they do not all work out perfect. This one just did. So I think nice and good. Okay. So if it doesn't square root evenly, that's fine. Go ahead and square it out. But if it does square root evenly, I said square root it all, so you're never going to leave it as a square root, so r is 13 in this case. So this time we got a whole number, sometimes you'll have a decimal, but always do that square root, okay? So now we're going to convert our x and y to theta. So it's tangent inverse of y over x. So what you should notice right away is one of those two numbers negative. Yep. So one of the original two numbers is negative. So that should tell you that I'm going to have to add something here in a second. So if one of the original two numbers is negative, that's when you have to look at those special or those extra things that you have to do. Is if you put a negative into tangent, it does not quite give you the right angle. It's close. So you just either you have to add a whole rotation or half rotation. So again, if one of those original two numbers is negative, that's when you have to do our little bit extra. So since one of them is negative, I know I'm going to have to do that right away. I'll go ahead and do tangent inverse of negative 12 divided by 5. Okay, but I got that originally. Negative 67.38. Okay? And like I said, it doesn't necessarily matter that we got a negative answer. What matters is that one of the original two numbers is negative. So now, since one of the original two numbers is negative, you have to look and see which one it is. So which number is negative? The y, just the y. So if just y is negative, what does it say on that sheet before? Add 360. So if just y is negative, you add 360 to that angle that tangent gave. So now we have r, and we have theta, and just like before, we're going to rewrite it as a coordinate because that's what our solution will be. This is the coordinate if it was an r and a theta.
If it's both, you add 180 and 360, or what happens if it's both?
If they're both negative, x trumps it, so add just 180. Okay, so this next one, we have the xy point 23. Are either one of them negative? No. So if you see that neither one of them are negative, then you don't have to worry about doing those extra addition things. That's just if one of the original two numbers is negative. So I won't have to worry about adding 360 or 180 with this one because neither x nor y are negative to start with. So we're going to convert this into an r and a theta. So I'll do r first. So 2 squared plus 3 squared. What's 2 squared? 4. What's 3 squared? Add those together. 13. Yep. So square root of 13 is not even, but I'm not looking for exact values here. We're just going to take that square root, get that decimal, 3.61. There's my r. So then it's tangent inverse of y over x. So make sure you y over x. So you do tangent inverse of 3 over 2. Right, 56.31. just talked about that a little bit. So again, if neither one of them are negative to start with, you don't have to do anything extra for theta. So I'm gonna write my final answers of coordinates. So there's my r and theta for that point. And we're gonna do one more. Questions so far? Last one. So what's negative 2 squared? 4. Yep, so that's 4. What's negative 4 squared? 16. Again, they're both negative, but when you square them, the negatives should go away. So 4 plus 16 is 20. Yep, so then we have to take the square root of 20, which isn't even, but it's going to be decimal. That's what's right. Okay, so it's 4.47. So there's our r. Now theta. Are we going to have to worry about adding something with this one? Are we going to have to add something with this one? Yep, because again, as long as one or both of the original two numbers is negative, you're going to have to add something. So this one, the important one is x. If x is negative, that outrules whatever you have to do with y. So if you notice that x is negative, we're going to have to add half a rotation this time. So if just y is negative, that's when you add a whole rotation. If x is negative at all, whether y is negative or not, that's the one that's more important. That's the one that kind of screws it up a little bit more. So then you're going to add a half a rotation with that. And part of the reason that is if you put 2 negatives into tangent, it's going to get rid of the negatives. So it's going to see this as 2, 4 instead of negative 2, negative 4. So that's why this one screws up. Because again, usually when we divide 2 negatives, it makes positive. So tangent doesn't realize that we're trying to convert it into a point. So you need to make sure that we keep it in quadrant 3. Okay. So we're going to do tangent inverse of negative 4 divided by negative 2, which gives us the angle of 63.43. But again, since x is negative, we have to fix our theta. And since x is negative, you add a half a rotation. So we're going to take that 63.43, we're going to add 180. So the actual angle should be 243.43. So you write it as a coordinate. And there's our r and theta. So the only thing you have to do, an extra thing other than just putting it in a different mode of your calculator, is with the theta. So if you're having to use the tangent formula, that's what you have to watch out. If am I putting negatives into that tangent formula? If I am, then you're gonna have to adjust your answer a little bit. So if just y is negative, add a whole rotation. If x is negative at all, add a half rotation. Now we're gonna get a worksheet that has just a mixture of all these different types of conversions. So the first page, both front and back, those are all r and theta format, and you're going to convert them into x and y. And then this last page are x's and y's, and you convert them into r's and thetas.